Hello everyone, welcome. This is Mary Magnuson, and on behalf of the Blandin Foundation, I'd like to welcome you to today's webinar on wireless broadband. It's complicated. This is one in a series of monthly webinars we're offering for our Blandin broadband communities and open to anyone with an interest in using technology to improve community. Before we begin, I'll point to the chat box at the lower left corner of your screen. To interact with us at any time during today's webinar, you can simply type your question or comment in the chat box. And now let's get started. Again, my name is Mary Magnuson, and I work here at the Blandin Foundation, and my job is to administer the Blandin Community Broadband Program. Joining me, hopefully at some point, is Bill Coleman of Community Technology Advisors, who I'm sure many of you know. Bill has been Blandin Foundation's primary broadband consultant for a number of years. Our plan today was to have Bill introduce our guest speaker, but I think that I'll just have him say a few words about himself and his company. His name is Albert Kangas, and he's the General Manager and Chief Operating Officer of Nucor Wireless. Thank you for joining us today, Albert.
Thank you, Mary, and I appreciate you and Bill reaching out to me and giving this opportunity where I can share a little bit of the information that we've gathered over the course of a few years and wireless and broadband and all of the things associated with wireless. So I do have a couple of little slides, and I would first like to start out by saying, Nanette, and hopefully I said your name right. Thank you very much for letting me borrow your name for this afternoon, and I'll try to do it justice. So we're here to talk about wireless and the fact that a lot of folks look at wireless as a very complicated industry and full of different things. So the next slide I'd like to go to is going to just talk a little bit about who Nucor is. I won't spend very much time on this, but Nucor Wireless is a company that was formed in 2008. The management and some of the ownership within Nucor dates back to wireless in 1988. We're involved with wireless operations, which at that point was Cellular 2000 and St. Cloud. That same company was also a Sprint affiliate. So a lot of the management here at Nucor, we're part of that team. And today we operate a network that provides services to over 300 different wireless sites throughout about 11 different states. The wireless elements that we take care of, and even though a lot of these elements are providing cell phone service, we certainly have elements that are providing broadband. Many of our partners use their networks just for providing fixed broadband or some sort of telemetry or mobile data type of service, while others certainly use it to provide mobile service as well. So we have a wide range of customers and partners that operate anywhere from 1 or 2 tower sites to some of them that operate multiple. So that being said, this next one should be the last one about that. Just gives you a little bit of an idea of all the different tower sites connected to the platform in St. Cloud, Minnesota, for the purpose of providing those broadband services to their community. So it is an upper Midwest type of deal. We've added a few more states in here, including Alaska, Indiana, and Oklahoma. So branching out a little bit across the Midwest, but that is what that looks like. On to the next one, we wanted to talk about simplifying wireless a little bit for this conversation. Acronyms is probably something that is in every industry. I don't know if I can talk to anybody that doesn't have an acronym for something. And probably what happens in the wireless industry, because it's a fairly small industry when it comes down to it, we use acronyms nobody else has really even heard of. So even when we talk to our telephone company partners that are used to acronyms in their own industry, the wireless acronyms are just new, something different. So what we have to do is we just have to remind ourselves that those acronyms have to be explained, whether it's LTE, meaning long-term evolution, or CDMA, meaning code division multiple access. Those are the types of things that we need to talk about. So Mary, I think you can still hear me, correct?
Yes, I can. I just muted myself.
Oh, sorry about that. I did lose my screen for a second. So
oh, you did?
I did. I think it's coming back.
Okay.
Sorry
Oh,
about
no.
that.
Oh, gosh. Yeah, no, you're not. Let's see, Nanette. Oh, you know what? You just got made back you know what happened is you just became a you became a participant and not a presenter.
Okay.
There you go.
I
Can
still
you
have
see
my
now?
slides, so I should be good.
Excellent. All right.
Sorry about that, little bit of glitch. And then the last thing is when you're talking about somebody in the wireless industry or with them, just ask them to explain what they're talking about, and they'll be more than comfortable. Just because some of these words get long, it's hard to explain what they are, so we tend to make it too simple and spit out letters instead of words. So, and then in the end, it's really just comes down to communications. You know, whether it's wireless or fiber to the premise, or simply any communications, it's connecting people and things, and the things are a critical thing as well when we look at communications, whether it's smart cars, connected cars, whether it's the agricultural industry. It's really connecting people and things, especially when we look at penetration of wireless devices throughout our country. We're at over 104%, I think. So many people are carrying multiple devices. There are devices in vehicles, devices on tractors, so it is an important part of communications. The advantages of a wireless network, I think the first one is mobility, but that doesn't necessarily mean that makes fixed broadband, mobility gives that an advantage. But mobility is an asset and an advantage that wireless has. One of my previous engineers would always say that once somebody can figure out how to drag a pair of wires or a fiber optic cable down the road with them in a vehicle when they need to use broadband, then maybe we have something. But until that, the wireless solutions are going to enable mobility. The other advantage for wireless is the faster deployment. We can have a wireless site up and running in a rural area within days if we really have all of the components such as the tower leases and that thing in place. You can use wireless backhaul. So the deployment can be very fast. Even when you look at public safety, there are Tiger teams that are set up to deploy wireless super fast to get communications into an area that needs it. So that is a huge advantage, and a lot of times we'll see wireless being deployed as a temporary solution until the facilities get put in place. And the next bullet is lower cost, and I put usually on there because we have seen some wireless costs that have gotten really high and start looking at doing a facilities-based solution a little cheaper. So you do have to look at the project and the solution and make sure they match up. Geographic boundaries, when you look at the telephone companies, they're assigned service areas, and they usually don't go outside of them from their own phone company unless they want to be a competitive local exchange carrier, and then they can cross those. From a wireless point of view, the areas are much bigger, so they're not townships or service exchanges. They're usually by MSAs or RSAs, usually multiple counties that form up a larger service area. So get a little bit more area to play in. And then with wireless, there are licensed options, which we'll get into a little bit, or unlicensed spectrum, which makes the ability for wireless to be engaged with by really anybody, whether it's a municipality, a telephone company, a cable operator, or a private entrepreneur. Those solutions can be deployed in these rural areas where our broadband is lacking. And then the ecosystem is something that we'll talk about too. As we look at the deployment of these networks, the ecosystem to make sure that devices are readily available, they're cost effective is a critical part. So here's a slide that you can take away. If you don't learn anything else today, this would be a couple of things to take away. From wireless, it operates on the spectrum, so RF spectrum. And the lower the frequency, the greater distance it will travel. And that may be a little bit in this, not quite the most accurate way to put it. But for example, if you look at your radio station on your vehicle, if you're listening to 94.9, that's 94.9 megahertz or million hertz. If you're listening to 104.7, that's 104.7 million hertz. At the 900 megahertz, that's a lower than, say, the 2400 megahertz or the 2.4 gigahertz. So the lower the frequency, typically the more distance you'll get out of that. Capacity for broadband, this is what we're struggling with today when we look at the need for streaming video and all of those type of things. It's usually dictated by the amount of spectrum. In other words, are you using a 1 megahertz slice of spectrum? Are you using a 5 megahertz chunk of spectrum? Or is it a 20 megahertz chunk of spectrum? The more spectrum, typically, the more bandwidth that's going to be shared across that network. The technology used, we've evolved from analog voice technology to digital standards such as CDMA or TDMA. We've gone on through the different things, and now we're at LTE from a mobile and broadband solution. There's WiMAX out there. The technology type really translates into how efficient is the spectrum at producing bandwidth. And usually what we're seeing is we like to say that we have a multiple of 5. If you have 1 megahertz spectrum, you should be able to get 5 megabits of bandwidth out of that. There's many variables that go into that. The other thing is the power. There's a transmitter in each radio. That transmitter puts out a certain amount of RF power or watts. Every user will use some of that. So once all of that power is gone, there really isn't the ability to add users or bandwidth to that, and then you have to add more or more radios to get that done. And then the third bullet, radio frequencies are absorbed, and that's in parallel to the first segment. Those frequencies are absorbed by all the materials around us, whether it's our bodies when you have a cell phone next to your head. You know, certainly if you point to a different direction, the signal might come in better just because there's mass in our body. There's certain materials within homes. There's trees. There's buildings. Everything will impact the ability for spectrum to be able to travel. And then we get into the areas where certain frequencies have what we call non-line of sight, where they will usually pass through materials, buildings, etc., a lot more easier than other ones. Where other technologies, we call it line of sight. Once you get above, say, 3 or 4 gigahertz, once you get into the 5 gigahertz, it really becomes more of a non-line of sight. There has to be a direct path between the modem or device that is receiving a signal and the antennas or the base stations that are broadcasting. So that was that one. And then within the radio technologies, there's typically 2 ways to send and receive this. One is frequency division duplex, or FDD, and the other one is time division duplex, or TDD. Most cellular operators use the FDD portion of it, so there's transmit receive frequencies. Other technologies such as WiMAX in most cases would use TDD, where there's just one common block of spectrum. We talked a little bit about buildings and such, but terrain and clutter have a significant impact on the ability for RF or radio frequencies to do what they are intending to do. So if we look at even the state of Minnesota, where we have our woodlands area, and then you get to the west and you start getting into the plains area, if we were to look at, say, a wireless carrier's footprint, the number of sites they have a lot more sites in these heavily wooded areas just because of the impact of that terrain and the clutter, if you will, trees on that signal. So terrain does play a critical role. Well, that's when you go down into a valley when you're driving on a road, or if you're near a mountainous area. Typically calls are lost in that type of thing, and you'll have the same issue on broadband, where it's hard to get that signal to a house or something like that if they're behind a hill or if they're embedded in a grove of trees. Gas-filled windows is another one that sounds odd, but the more energy efficient windows that are being put in, RF has a really tough time getting through some of those. So even from a broadband point of view, if we're putting a modem inside a home, we may be better off going away from a window and through the materials in the wall of the house, just because the windows are really good at absorbing that frequency. The types of spectrum, this is where we can probably spend a little bit more time, even though there's not a lot on the on the chart there, there's unlicensed spectrum, there's licensed spectrum, and what we call pseudo-unlicensed spectrum, and we'll get into each one of these. And there's a few other ones in here, and quite honestly, even in the unlicensed examples, within that, some of that same spectrum is actually licensed, and they're shared, so it's a combination of unlicensed and licensed. So we'll start off with the most common spectrum that's really deployed globally. Every cell phone in almost the world being deployed right now has a Wi-Fi radio in it. With that, it's the scale is huge. There's so many devices that the cost of a Wi-Fi router is really low. The same spectrum has been used for point-to-point microwave, cordless phones, the wireless band, so point-to-multi wireless broadband, we've used 2.4 for. What that means is it's a very valuable spectrum, but everybody is using it, and it becomes kind of noisy. So what we're starting to see even on Wi-Fi is that the Wi-Fi radios and devices that are now being deployed out there actually don't have any of the 2.4 gigahertz spectrum in it. They've gone to the 5.1 gigahertz. So as we look at the spectrum, the more it gets used, the noisier it is. Sometimes we have to move away from it, and that's somewhat of an example of what we've seen happen on the 2.4. The 900 is probably one of the most common spectrums that was used early on, maybe 6-7 years ago. Pretty much all the cordless phones were operating on 900 megahertz, and there's not a lot there. It's the band goes from 902 megahertz to 928 megahertz. So it's a finite amount of spectrum and a lot of people using it. Most baby monitors were on that. What we ended up seeing is that with this spectrum, the impact from interference from people using it, one day that network was being used for wireless broadband and serving rural communities, and people were getting access to internet where they couldn't get it through their phone company provider. And then all of a sudden it started to noise up, and that system started to shrink in its coverage just because the interference got a little bit more. So we aren't seeing as much 900 megahertz spectrum being used for wireless broadband, but it still is a very viable solution in areas where there isn't any interference. The other unlicensed spectrum that's probably the most common is the 5 gigahertz band, and it ranges all the way from 5.1 gigahertz all the way up to 5.8 gigahertz. And there's a lot of spectrum here, and a lot of folks are using them. Everything from Wi-Fi to wireless broadband solutions, serving rural and urban communities. Point-to-point microwave, the ability for somebody to get a high amount of bandwidth from one point to the other with just the 2 points talking. So, and then now the tier 1 operators are adding LTE technology. So the same technology that you see on your cell phones operating in the licensed spectrum will now start to appear in the unlicensed spectrum band, because the tier 1 operators have spent really a lot of money on their wireless spectrum that's licensed, and the amount of bandwidth that's going over it can no longer sustain how much spectrum they have, and they have to keep on buying more. So they're looking at places to offload that bandwidth and put it onto more cost-effective technology, and in urban areas, that's what they're looking at doing. So now on to the next one for licensed spectrum. This is the spectrum, again, that most wireless carriers operate that are commercial carriers, such as Verizon or AT&T. But it's not just that. It's radio stations, it's TV stations, it's military, it's anything you can think of that people are using wireless for. Typically is regulated by the FCC, and that spectrum is allocated in cases. So the point-to-point microwave, even though unlicensed can be used for this, a lot of that is used as licensed spectrum. And there's multiple bands that are used, everything from 6 gigahertz to 11 gigahertz to 18 to 23 to 31, all the way up. And it's a real valuable use of the spectrum, because typically those frequencies can be reused and reused and reused, a lot of times in geographic areas, as long as they don't interfere with each other. And what we've seen on the commercial spectrum, such as the cellular spectrums and the PCS spectrums, and most recently the AWS spectrum, is the FCC is auctioning this spectrum off as really a national resource, and companies are using the spectrum to add on to their capabilities, whether it's a broadband network or whether it's a cellular network. And as an example, the most recent AWS auction that just completed here about a month ago raised $41 billion for the federal government, which they will, I'm sure, find a use for. So with that being said, more and more of these auctions will be held, more spectrum will be handed out, but companies and individuals will be paying a lot of money for that spectrum, which makes it a little difficult for the smaller operators to play in that field. So then that's what's forcing some of our operators to go into the unlicensed area or some sort of partnership with companies that do have spectrum. This by no means I expect anybody to get anything out of. It's an eye chart at best, but it represents the spectrum across the United States that the FCC licenses and manages. And you'll see all these little chunks in here, and it goes from 0 to 300 gigahertz and covers all of the TV stations and cellular bands. And it gets to be a very complicated arrangement of who owns what spectrum, who can use what where. So just take this as a note that it is a managed asset that the federal government manages, and they put fairly strict policies on how those frequencies can and cannot be used. So now we'll get into some of the technologies that are used over these wireless networks, and the first part of it is more of an example of the evolution of wireless and what it was set out to do in years gone by and what it's being used today. For example, in the 1980s, when the first cellular voice, it was a fairly simple system. 30 kilohertz of spectrum, 30,000 hertz of spectrum was used for one voice call. And what happened is too many people started using the network, and there was a finite amount of spectrum to use, and it became congested. So the FCC started making additional frequencies available. But before they could do that, carriers had to figure out a way to put more people on the asset that they had. So then there came the need for the digital technologies, where CDMA came into play, where they were able to take and consolidate hundreds of people across a common channel, and it made it much more efficient to operate on that. TDMA came around, they took that same 30,000 or 30 kilohertz channel and made, instead of one person able to use it, 3. So that was a 3-to-1 improvement. And as we grew, that kept on going up. So GSM became the digital standard across the world for carriers, with the exception of the United States and Asia, where CDMA was more prevalent. And today it's about 50-50. So GSM was adopted, and as it kept on going, the need to have data on these wireless devices and on these technologies enhanced. CDMA added a technology called EVDO, and gosh, I should have practiced that one, but basically gave the users to share about 3 megabits per sector. So you would have a wireless carrier like Sprint or Verizon, and they would usually have 3 antennas or sectors on a tower site, and then each one of those sectors would have the ability to share 3 megabits. So certainly not the broadband that we're seeing out there today, but it was better than dial-up back in those days, and folks were starting to use data on their handsets and, quite honestly, using CDMA in homes for residential broadband. GSM kind of did a leapfrog of that. They added the ability to put 14.4 megabits on a sector. Granted, it was a bigger channel spectrum, but it certainly added more bandwidth. And then WiMAX and LTE were being evaluated. WiMAX, we still see that out there today from a fixed broadband solution. There's a lot of WiMAX throughout the United States. However, LTE kind of took over because the Tier 1 operators did not choose WiMAX as the technology of choice in the handset. So with that being said, WiMAX has not grown maybe to the extent that everybody wanted it to. There's a lot of networks out there that are deploying. They are still growing, and it'll probably be maintained for a while. but there are significant advantages of LTE over WiMAX. So we're starting to see broadband networks that are designed just for fixed broadband being deployed with LTE, and it's not necessarily connecting to networks like Nucor has. Nucor has a hosted switching platform that LTE carriers can connect to, and it's a very complicated core and really, really expensive. So there are ways to operate LTE in a more cost-effective manner without the huge core costs associated with mobility and such. So, but LTE does appear to be the technology of the future from a broadband point of view. And this next one I won't dwell on too long, but it talks about scale and why we're seeing so many companies that have been in the business for a while, even say, for example, Clearwire, which was started in St. Cloud, Minnesota. St. Cloud and Jacksonville, Florida were two of the Clearwire, and they grew and they added networks in Chicago and Minneapolis. But at a point, they couldn't keep up with the demand. And what happened is they looked at their technology and they decided to basically go and partner with Sprint, where Sprint was going to now take that technology or that spectrum and add in for handsets. So, the Clearwire that you see out there today in some of the parts of Minnesota may not be there as that spectrum is repurposed for other things. And it was mostly due to scale. It's not, tens and hundreds of thousands of devices that make a business work. It's millions. And, handset manufacturers or modem manufacturers aren't interested in building smaller scale. They need a lot of quantities in order to be profitable. So that's why some of these smaller operators just have to either consolidate or aggregate, like some of our Nucor partners, or look at, is that the right business for them to be in? So how can our rural areas take advantage of what's out there for being able to deliver wireless broadband, either by using licensed spectrum or the low-cost spectrum? And the example WiMAX was titled the most disruptive technology not that many years back, but things changed, and it's not necessarily the disruptive technology that we all thought it was going to be. Something else took its place. A lot of that had to do with WiMAX was a combination of a standardized protocol. So there were chipset manufacturers that received revenue from the chipsets, and everybody had to kind of make their platforms work to a certain standard, which did add some cost in it. And where you'll see proprietary technologies, whether it's an example of Motorola or Ubiquiti, they have their own standardized things now, and typically results in lower costs. The negative is you can't take a Motorola proprietary technology and put it onto a base station that is made by Ubiquiti. So that's a disadvantage of having a non-standard one, but the costs and the ability to deploy them and not having the core networks associated with the mobility network are probably outweighed the negatives. And the last partner, or the last note I'd have on this slide is we've seen a lot of companies, whether they're local phone companies or municipalities or just carriers, being able to just share knowledge and create a buying group and just leverage the assets to bring that scale back. So if you take 10 small companies and add them together, they usually can get the attention of some of the manufacturers to get things done for them. So what is driving our broadband needs? And this shouldn't be anything new, but we'll reiterate it again. I was at a company, even in the technology industry, where we had probably 50 people operating on an office environment, and we had a 1.5 or a T1 to the internet for connection, because it was really web searches, sending files back and forth, but the streaming video was not part of what we were doing. That circuit really handled the needs of our business and other businesses that size as well. Now it's almost impossible for that same 1.5 megabit circuit to serve a residential broadband solution with just one family. So streaming video is what has really changed that. Today, nearly 60%, in some cases more than 60% of the global broadband consumption is from one company and one application, which is Netflix. And it's maybe good or bad. With that, when you look at what people's needs are, it's a lot of entertainment, but that has driven the need for broadband. And whether it's costs of the different media that they're looking at, whether it's cable TV or such, they're looking to receive many of their entertainment needs. There's a lot of work from home folks that need broadband. Many of the applications are cloud-based, so it's not just because you're sending a picture back and forth. You're actually sending files back and forth, whether you're using Google Drive, where you need to have constant connection to the internet, reliable, and need to be fast in order for people to do their work. So, but broadband is being affected by video, whether good or bad. I would have to say, even from a YouTube point of view, I was never really a fan until I started using it to learn how to do things. And it's a great educational tool as well as an entertainment tool. And the last item, broadband utilization, really does span all generations and cultures, and it really should be considered critical infrastructure. I think it already is, but maybe not officially. But it is the mechanism that drives people's needs to be able to work from home, do their classroom, work at home. For example, I have daughters. They were each able to shave off 1 year of college education by doing post-secondary in high school. And from an individual, what that meant is that shaved off probably $20,000 per year of education needs because they were able to accomplish it at home and at high school. So it does impact the bottom line of families by having access to broadband. So I'm going to try to go through this pretty quick because probably everybody's getting a little bored. This is kind of a quick rule of thumb, and it's a variable that keeps on changing. But when we engineer systems, we try to allocate usage to the network at our usage of the network during the busy hour to an individual user. And we're using 200 kilobits as that impact to the busy hour usage. So what that can do is you can take, if you want to serve 100 users off of a site, you can take that and you can calculate how much you need for bandwidth. Also, you need to know how much spectrum you have. For example, a T system that uses 20 megahertz spectrum, it can usually deliver about 40 megabits of capacity per second. Once you have these values, you can start to do some engineering on, if I want to deploy a system, what is it going to cost, how much do I need, etc. So hopefully that helps a little bit. Spectrum quality and quantity are really critical. Deploying a broadband network over an unlicensed network versus licensed spectrum. The customer service part of that is certainly to be taken into consideration because there could be something happening in the network that you have no control over, so such as somebody else using the same spectrum that you're using. And then you have to do coordination with that other carrier to make sure that you can operate in the same area. So an example of that is the 3.65 spectrum. It's what we call pseudo unlicensed. So there's 50 megahertz of spectrum that's available for broadband to anybody that wants to apply for a nationwide license and spend $200. I know that sounds kind of simple, but that's what it is. And then with that, it is pseudo licensed, where you do have to register all of the sites that you have. However, there's no first come, first served type of deal. So if another carrier wants to come into a market that's using 3.65, the two carriers do have to negotiate and work out a plan. But it is something that's manageable, especially in a little bit more rural areas. So the subscriber installations, this is fairly critical, whether it's one subscriber in a rural area or 1,000 subscribers in a metropolitan area. The installation and the type of modem that's being used for broadband is a big deal, mostly because, again, of that other slide that talked about scale. Many outdoor, say, LTE modems being manufactured as indoor broadband modems. So thus the indoors are a little bit more cost effective. They don't have to be hardened to survive negative 40 degrees weather in northern Minnesota. So the cost of the device is fairly important. The higher frequencies like 3.65 or 5 gig are going to dictate that those modems probably have to go outside, so it's an outdoor installation. And then the the technologies that we're using on wireless really have to be taken into consideration, because the way that the wireless systems work, the better the signal quality, the better the signal level, the less those devices have to work, both at the device and at the base station. So we always tell our folks that, you know, there's no such thing as having too good a signal. You want to have the best possible signal quality and the best possible signal level, and it goes into what we call a modulation scheme. So the better that signal level and quality, usually the higher the modulation scheme, which results in more bandwidth per megahertz of spectrum. So that could be another takeaway for y'all, is try not to put in a modem just because it kind of works. That impacts the whole network. So we tell some of our folks, just because you can provide service to a customer that's on the edge and it kind of works, you're probably doing more damage to your overall network by putting them on there than telling them that you can't serve them, which is sometimes really hard to do, because we all want to try to serve all of our customers with whatever we can get to them. Base station trends, this is what's on the tower. What we're seeing now, and this didn't start that long ago, we're starting to see the base stations be put right up near the antennas on the towers. There still are carriers that are putting equipment into shelters or cabinets on the ground and running coax to the base station. But due to the loss and the amount of spectrum that is being used, even the biggest of the big are starting to put their transmitters up on the towers. The reliability factor has improved greatly from the vendors, whether it's Motorola or Ubiquiti or Ericsson, Nokia, Alcatel-Lucent. They're all making equipment that's a lot better. It's hardened, and it can survive the elements and have a lot better mean time before failure. We're also seeing distributed antenna systems and in-building solutions. Just like your cell phone may not work always in your house, if the carrier can't deploy additional towers in your area, they may ask you to put in what we call a femtocell. It's a big trend. Everybody wants their devices, broadband devices, to work wherever they're at. So in-building solutions are springing up all over the place. And then the other thing that we're seeing is the average bandwidth that shows up at a communications tower, whether it's a Tier 1 operator or a broadband service provider, typically is starting to be in that 100 megabits per tower location. I know we all want to get to a gigabit to the home, and hopefully we get there soon. But from a wireless point of view, that's probably not going to be feasible. However, it can deliver reliable broadband, in that 2 to 5, maybe even 10 megabit range, sooner rather than later. And eventually, I think, we'll get to the point where we have facilities to some of our places. But right now, it's not. So here's my summary. It's wireless is a great solution to provide broadband. It's not just for voice anymore. It can do broadband. However, the streaming video has impacted not only wireless but all service providers that are providing internet to their customers. But wireless is impacted a little bit more negatively just due to the finite resources, cost of the spectrum, etc. However, in rural areas where you're dealing with maybe a national or regional telephone company, those areas may not receive that broadband through the ground that some of our urban counterparts have. So wireless is going to need to fill that void for quite a while, I think, until there's some sort of subsidy mechanism to be put in place that do that. And so with that, a mix of fiber, copper, coax, and wireless is going to be used to meet the demand, and especially in our rural areas. And when I say rural, it doesn't mean that it's in the middle of Minnesota where there's nobody around. We see population centers where there's 20,000 people, and you only have to go a half a mile away from those people, and they don't have even a quality DSL product, much less a fiber product. So we should be careful when we say rural, because those rural needs really are right outside our urban areas as well. And then my last summary bullet point is that I don't believe wireless can meet everybody's needs, and I think everybody would agree with that. But it can be a really important tool in the toolbox, whether you're in a municipality, a county government trying to enhance the effectiveness of the communication solution in your area through wireless, a telephone company provider, or an entrepreneur. It can be a very good solution, and it should be looked at to provide those capabilities. And I do have a couple of other slides, but I don't think I'll spend very much time on them and hand it back over to Mary. They're here to be available on the slides afterwards, but just a couple of examples of a wireless network and some of the cost factors associated with operating that network, and kind of some engineering information. So Mary, can I hand it back over to you?
You sure can. And Bill, are you on? Are you? Can we hear you now?
I think so.
Oh, we can.
Hey.
Yes, we can.
Hello, everyone.
Welcome, Bill.
Thank you. Albert, what, in the fiber world, Google has community checklists about how to, entice providers to come deliver fiber. What's on that checklist for communities for wireless? Is it vertical real estate the biggest thing? Towers?
I would say that is the one of the bigger things, because there needs to be the ability to serve an area, and then we have to do it through towers or buildings or silos. Sometimes it's difficult to get permitting approval for some of those things. So I think if there's the ability for the providers to work with their entities that manage the permitting process, those structures can be put up in the right spots with the least amount of impact on the residents, but yet provide a really critical need. And what we're seeing is there's so many national companies that are out there just building towers, and they do it because that's a business for them. They're used to serving the big carriers. It becomes really cost disadvantageous to work with some of those national tower companies to put up a wireless internet service provider base station. We're trying to deal with a tower lease in sub 1,000, and they're usually around $2,000. So.
Okay. Pam Walling from West Central Telephone says, do you have any sense of how the new FCC net neutrality rules will affect wireless business?
Certainly not an expert on this, Pam, but what I can tell you is, with video being the greatest impact on all our internet service providers, including wireless, there won't be the ability to cap speeds, if you will. So in other words, if a company is selling a 3 megabit wireless service to somebody, we're not going to be able to say, okay, if you're streaming Netflix, we're going to limit that service to 1 megabit, and everything else can go along. So I would say it's going to have a significant impact on the cost of providing wireless broadband services and the quality, because without the ability to control those HD video feeds, we won't be able to take and say, hey, don't let this be in HD, let it be at a lower resolution. So when I can understand those things won't be allowed, Pam, which certainly could impact the cost of deploying it over wireless.
Well, and this one kind of question goes along with that from Jacob Rickey. Will Verizon or other national providers ever operate without data caps?
So I don't know that answer, Jacob. I can tell you it'd be really, really hard for them to do it. Again, when Spectrum is going for $41 billion across the country, that's what they have to operate it on. So they may get to the point where they offer their data if they deploy, say, a Wi-Fi network over Spectrum that's not licensed, which may not be that far around the corner, where you start looking at wireless operators like Verizon and AT&T deploying, kind of lower height, lower coverage Wi-Fi networks in a higher capacity need area. You may see some of that, but over a macro network, it's really difficult as an operator to support that.
Then one final question for you, and maybe you talked about this a little bit before I got on. What about FirstNet and that as a tool for rural broadband development?
So FirstNet, if the folks here on the call don't know what that is, that's a nationwide, so it's a national program. FirstNet is a portion of NTIA. So FirstNet's goal is to provide a nationwide broadband network for public safety. So they have the spectrum already. They have 20 megahertz of spectrum that covers the entire country, and it's in the 700 megahertz band, so it's the beachfront property spectrum. And the goal there is to provide local sheriffs, ambulance, police officers, firefighters, the ability to use a nationwide network so the devices all work wherever there's networks, that when there's a national event such as a hurricane or flash flooding, that network should be a little bit more resilient than the commercial networks, and it won't be impacted by overuse when you have some sort of a tragedy like that. So the issue there is, or the challenge is, how do we take advantage as a community of that excess bandwidth that is on that FirstNet spectrum when it's not being used? So we're currently working on projects right now in the state of Minnesota. It's one of only a few in the country where a private entity is actually working with FirstNet in the state of Minnesota to see if they can fit into that spectrum for low utilization bandwidth. I doubt if it will be able to be used for residential broadband, which is probably some of the interest, but it certainly can be used for maybe more critical infrastructure, government-related things, even private sector where there's an appetite to have access to bandwidth, but knowing that during an event where there's an emergency and FirstNet needs to take control of that traffic would be put to the side and put at a lower priority. So it's an option.
FirstNet going to build their own towers?
So for FirstNet, again, it's a national platform. And however the states, our governor will have to decide if they're going to opt into the program or opt out. The state of Minnesota is in a really, really good spot where our leaders within states, the public safety sector, there's already over 300 towers throughout Minnesota that the state of Minnesota owns and operates. And those, quite honestly, are a really good asset for any broadband provider that wants to provide their own service. Usually when I talk about the national carriers, like the American Tower and such, it's going to be a lot more effective to go and work with the state of Minnesota to determine if they have space on their tower. So I kind of went around there. We'll see how this pilot project goes. Hopefully that spectrum can be used to benefit everybody in the state of Minnesota.
Okay. And then Jacob's back with a question about why is the quality of satellite so poor?
So I think what you see on satellite, a lot of people are using it. It's just like anything else. It's a shared median. That signal has to go a long ways up and a long ways down. 23 miles up, I think, is what it is, right? Or sorry, it's more than that. But it has a long ways to travel, so the latency is always usually a little higher. The bandwidth is fairly good. So when you look at some of the satellite services, they've really upped their game and they're able to deliver some good bandwidth. But those satellite networks are also capped just like the Tier 1 carriers. So you run out of your bandwidth in a given month really quick if you start downloading movies and such. So from that point of view, they've gotten much, much better. And it provides a really good solution for when there's no other options, except they run into the same issue. They have to cap their data usage in a given month. And the latency is a little hard to work, especially anybody doing gaming. It's pretty tough to do that over satellite.
I always say telesurgery is difficult over satellite. Well, with that, I want to, I think Jacob's question about the caps on satellite, I think that comes to the same piece. The capacity, shared capacity is low, so they split it up so that everyone can have some.
Correct.
I suppose setting satellites up is expensive too. So
that is.
So I want to thank Albert for the presentation, and I think I was certainly looking at the slides, and then I got to come on for most of the event. So one of the reasons, usually we have multiple provider speakers, but I think satellite is complicated, and we wanted to have a real systematic approach to the presentation today, which I think you got. Mary is going to upload this presentation, and not only the slides, but the audio, and attendees will get a link to that when that is accomplished. And I want to thank Albert for his time and attention and willingness to share. He's also an active member of the Sherburne County Blandin Broadband team, so we appreciate that as well. Thank you, Albert.
Well, thank you for inviting me.
Yes, thanks, Albert, and thank you, Bill, for bearing with us and being patient today. That was kind of an interesting start to the webinar. Hopefully next webinar will go a lot smoother. It's going to be on Thursday, April 9th from 3 to 4 p.m. and the topic is going to be organizing the community around key broadband topics, creating the right team. Thanks everyone for attending and have a great rest of your day.